Hey, welcome, fellas, to this wonderful series of demystifying LeetCode. In this video, we will discuss the problem merge two sorted lists of LeetCode. As always, I have provided the link to the problem in the description section of this video. And as always, I strongly recommend to solve the question on your own. Also, if you have an alternative, better, or a simpler approach, do comment out your approach in the comment section below. So let's move straight to question. So we have to merge two sorted lists and return the answer as a sorted list. The list should be made by splicing together the nodes of the first two lists. Example 1, we have two linked lists 1, 2, 4 and null and 1, 3, 4 and null. We merge them and get the output as 1, 1, 2, 3, 4, 4 and null. Since the problem is quite self-explanatory, we simply begin discussing our approach. So we want to return a new list. As every linked list has a head, we create the new linked list head pointer and set it to null. Now we have two linked lists with L1 and L2 as the respective head pointers. Now the head pointer of the linked list with list value will be inserted into the rear of the new linked list. That is the linked list with the head pointer variable new head, which is initially null. And after such insertion is done, the pointer of the head of the linked list to which the inserted node belongs is updated to point to the next node of the list, while the head pointer of the other list remains intact. Now again, the value of the head pointer of both the lists are compared. The node having the lesser value is again inserted into the right of the new list, and correspondingly the head is compared. We do this repeatedly until all the nodes of both the linked lists are inserted into the new list. Okay, so we will create a insert rear function that shall maintain a tail pointer of the new list. The insertion at the rear end shall take a constant time. We will insert all the nodes of both the lists. Say the first list L1 has the length of n1 and the second list L2 has a length of n2. So we will run the insert here function for n1 plus n2 alterations, causing our time complexity for the problem to be of the order of n1 plus n2. Okay, so with all the brainstorming done, we jump right to code. So I create the new head of the final linked list and set it to null. Now I create the insert rear function which takes in the head of the linked list and the pointer of the node to be inserted. Since the new node to be inserted right now may actually be somewhere in the middle of the linked list, we manually set the next pointer of the node to point to null before insertion. We check if the list has no nodes. Then we simply make the inserted node the head as well as the tail. If the list has some nodes, that means we already have the head and the tail created. So we simply insert the new node at the tail of the linked list and make the tail pointer point to the newly inserted node. Now we begin writing our merge two lists function, which takes the head pointer of both the lists. We make copies for the heads of both the linked lists L1 and L2, that is copy A and copy B, and loop over until both the head pointers L1 and L2 become null. Now we want to compare the value of both the nodes that are pointed by L1 and L2. We can only safely do this if both L1 and L2 are not null. If either of them is null, we simply update the other node and insert the other node at the rear end of the new list. However, if both L1 and L2 are not null, we insert the node with the lesser value and update the corresponding head. Finally, when the loop is over, that means all the nodes have been successfully inserted, we simply return the new head. So let me run the code. Notice it does work for the sample test cases. So I hit submit and I get a success result. The runtime is 4 milliseconds and it is faster than 95.89% of C++ online submissions for merge to sorted lists. Memory usage is 14.9 MB, which is less than 18.14% of C++ online submissions for merge to sorted lists. The time complexity is the order of n1 plus n2, where n1 and n2 are the length of the linked lists. Well, this was all for this video. Do like this video and share it with your friends and subscribe to iTalk Code. Till then, happy coding.